Welcome back, mathematicians. We've already learned how to simplify, multiply, divide, add, and subtract rational expressions. Today we're putting all of that together to handle something that looks a lot scarier than it actually is, complex fractions. A complex fraction is just a big fraction that has smaller fractions in the numerator, the denominator, or both. The good news, the process is the same every time. Simplify the top, simplify the bottom, then rewrite the problem as a division and simplify again. In this lesson, we're going to start with a quick warm-up where you'll see that a complex fraction is just a division of two regular fractions. Then we'll try a medium level problem, like this one, where we'll practice finding a least common denominator inside the numerator. And finally, we'll finish with a challenge problem that looks super messy at first, but breaks down step by step into something clean and manageable. Don't forget that I have a free worksheet that you can download that follows these exact lessons for you to practice. Let's dive in. So the first step we're always going to check for is that things in the numerator and things in the denominator are simplified. Remember, our order of operation tells us we must simplify the top, then simplify the bottom, then divide. Divide comes last. So let's start off by just checking. Is the numerator simplified? Yes, 1/2 doesn't get any smaller than that. Is the denominator simplified? Yes, 3/4 doesn't get any smaller than that. Our second step then is to convert it to a division problem. How do we do that? First of all, don't forget that ratios and fractions mean to divide. So all we have to do is think about this big fraction sign as a division symbol, and we're going to rewrite our problem. So we have 1/2, and we're going to rewrite it as divided by 3/4, just like this. Once we do that, that becomes fraction division, which we've been doing since elementary school. In order to divide, we are going to turn this into a multiplication problem. We keep the first fraction. We turn the division sign into a multiplication sign. And then we take the reciprocal of the second fraction. Reciprocal is when we flip something upside down. So in this case, we have 3/4. We're going to flip it upside down to make it 4/3. You can flip anything upside down. That's taking the reciprocal. X over y becomes y over x. If you have 1 over 6, the reciprocal is 6 over 1, or just 6. This is what reciprocal means. Let's move our problem down a little bit so we have a little bit of space. And now multiplication of fractions is just multiplying across the top, multiplying across the bottom, and making sure to simplify. 1 times 4 is 4. 2 times 3 is 6. Both of these can be divided by 2. So we're going to divide the top and divide the bottom. Our final answer then is 2/3. Let's try a harder one. So as you can see, the numerator is no longer as simple as possible. The denominator is, so we need to do a little bit of work with the numerator first. That means that I can actually rewrite the denominator and keep it exactly as it is for now. So we're going to look at making a common denominator for the numerator. There's a pretty cool trick where we can think to ourselves, 2 times 3 ends up being the common denominator that we're looking for. So we're looking for a common denominator of 6, like this. In order to get to 6, this side needs a 2. So I can multiply by 2 over 2. This side needs a 3. So I can multiply by 3 over 3. Remember, if we multiply by anything over itself, we're really multiplying times the number 1. And anything times 1 is itself, so it's not changing it. It's just rearranging its form. 3 times 2 is 6 here, 3 times 2 is 6 here, so I know I'm going to end up with the common denominator of 6. So all I have to do is multiply the numerators. 3 times x is 3x, plus 1 times 2 is 2. This gives me a numerator that is as simple as it can get, and a denominator that's as simple as it can get. There is no factoring that I can do here that would make this more simple. Now I'm ready to convert it to division. Remember, what we're going to do is just think about this fraction sign, the big one, as a division sign. And we're going to rewrite our two fractions. So we have 3x plus 2 over 6 divided by x over 6. Our next step then is to convert that division sign into multiplication. Remember, to do that, we're going to keep the first fraction. So we keep this fraction, and we multiply by the reciprocal of this fraction. So we have 6 over x. Remember that when we are multiplying fractions, it's as if this is really a long fraction sign and everything is just being multiplied together. So if we have the same thing in the numerator as we do in the denominator, we can cancel. So these two 6's cancel each other out. Now we can work with what we have left. On the top, we have 3x plus 2. And on the bottom, we have just an x. And that's our final answer. Because this work is in the Algebra 2, Pre-Calculus, Trigonometry, College Algebra level, we also need to get used to qualifying that x cannot equal 0. So whenever you have a variable in the denominator like this, it's helpful to start thinking about what x is not able to be. Now let's do one that looks a little bit crazy. It's actually not as bad as you might think if you really think about these as two separate problems. We're going to work with 4m over 5n plus n squared over 10m squared by itself. Then we're going to work with 1 over n squared plus 1 over 2mn by itself. And I've just realized I need to give myself a little bit more room here because of common denominator work. So let's tackle the numerator first. On this side, we have 5n. On this side, we have 10m squared. If we think about the fact that a 5 belongs inside the 10, in order to turn 5 into 10, we only need to multiply by 2. Oops, let me go back and get yellow instead. It just shows up a little better. Now that'll turn this to 10, and that's already 10, so we're good. But here we have an n, and here we have an m squared. So we need to give this side an m squared and this side an n. And now if we look at this, they're the common denominator. But we can't just multiply by n on the bottom or 2m squared on the bottom. We have to multiply the numerator as well. Now we're going to rewrite with our one common denominator of 10 m squared n. And in the numerator, 2 times 4 is 8, m squared times m is m cubed. N squared times n is n cubed. And that's our numerator. Let's do the same thing for the denominator. On this side, we have two n's, n squared, but there's only one here. So we have to give this side an extra one. On this side, we have two m, and that's not here at all. Now if you look, they have the same denominator, 2m n squared. And of course, that's what we need to make our numerator. So now we're going to combine these to a single common denominator of 2m n squared. 2m times 1 is 2m. 1 times n is n. And we're done. Now remember, even though this was a lot of work, this was our numerator from up here. This was our denominator from up here. So we're going to rewrite it now as a division problem. We're going to keep the first fraction. And we're going to divide the second fraction. So remember, we're thinking about this as a giant division symbol. Now, because we're going to need a little bit of room to work with this fraction, I'm going to shift some things around. I'm going to take this side work where we simplified the numerator and the denominator, and I'm going to tuck it away up here after moving this down into our workspace. Now I know you don't have the ability to do that on your paper, but hopefully you are working with a very nice long sheet of paper and you would just keep working downward and downward. Now the first thing we need to do before we turn this into a multiplication problem is to make sure that these are factored as much as they can be. And I notice that in this numerator, we have a sum of cubes. Remember that a sum of cubes is when you have an entire cubic term added to another cubic term. And the number 8 can be written as 2 cubed. Now that we have all cubes, we can use the formula a plus b times a squared minus ab plus b cubed. And we know that a, in this case, is 2m, and b is n. So we're going to change the form of that numerator. We're going to rewrite it now as 2m plus n 4m squared minus 2mn plus n cubed. The denominator stays as 10m squared n. And to this, we are going to multiply the reciprocal of our second fraction. Let's go ahead and take the reciprocal now. 2mn squared moves to the top, and 2m plus n moves to the bottom. And we're very happy that it does, because if you look, we are going to be able to cancel out a couple of things. First of all, remember that multiplication means that we're really just multiplying everything in the numerator together, everything in the denominator together, and that we can cancel things out even if they're not perfectly lined up. And 2m plus n and 2m plus n can go away. 2 and 10 can simplify each other. There's 1m here and 2 here, 2 n's here and 1 here that can all go away. And now if you look closely, the only thing I have in the numerator is a single n right here, kind of hidden, and then this quadratic. I would take a quick check in any of these cases and see whether or not you have factored that entirely. I also just realized that I made a math mistake. That's supposed to be squared, not cubed. And so is this one. And so is this one. If that was confusing you at all, good job. You would have caught my mistake in my classroom. In the denominator, the only thing we have left is a 5 and an m. And now we're done. Don't forget that there's a worksheet to be able to practice all of this. There's 2 challenge problems that look like this one, but the rest are lots of practice with the previous easy and medium level of these complex fractions. Good luck, mathematicians.